Okay. It's done, Luana?
Yes, it's recording.
Okay. Good evening, everybody. My name is Adrian Correndo, and I'm a member of the Stats and Programming Committee of the Agronomy Graduate Student Association at K-State. And on behalf of the AGSA, we say welcome, everybody, to the first Applied Python workshop. And we say thank you to our instructor today and tomorrow, Dr. Patrick Yanni, who is an assistant professor in software management at K-State, and he has a great expertise on Python programming, and he was really willing to help us supporting these workshop activities. Being that said, I will give the command to Dr. Patrick Yanni.
Okay. Thank you, Adrian. Let me just share the links of while I say a few words, you can start looking at the material. So let me just share that in the chat quickly. There you go. Okay, well, yes, I'm not an expert in Python. I use different languages for research. One of my main languages that I use is MATLAB. It's just, it saves a lot of time, but you know, Python can do things other languages cannot do, and it's fairly easy to learn at the beginning. So overall, programming had a really strong impact on my career. I learned how to code when I was in the last semester of my master's, and then it really helped me through my PhD and now through my professional career here at K-State. So I have to say that it's probably one of the most important skills or assets that I learned in grad school. And so that's why I'm you know, willing to teach other students and other people how to code, because it really gives you, you know, it empowers you to do things that you know, we were unable to do before just using regular spreadsheets. So it's, you know, if you are creative, if you like to you know, to invent things or to create your own data analysis and explore data and come up with new approaches, you know, coding is probably the way to go. So today, what I will do, I'm not sure exactly how many people are planning to code in real time. So I cannot ask you to raise your hand. I guess I can maybe in Zoom, or just write in the chat whether you're planning to just listen and watch, or whether you're planning to actually code live while I'm showing you the code. I think that will be important so that I can adjust the pace of the lecture or the workshop. Okay, I see one person, two, okay. I can.
If you want.
Okay, there you go. I just want to more or less know exactly how many people are just watching for the sake of it's okay if you're doing something else, you can just assume that this is like the FM radio of agronomy. But okay, well, I will try to go slow, so to give you time. One thing that we cannot do, unfortunately, is to troubleshoot your code, and this is usually something that happens in the classroom. I can go around and quickly find what went wrong. Usually it's a comma or a space or something extra that is causing some problems. So that is why I share with you in that Github repository the entire content for today's class. So if you get lost or something is not working, then at least you can run that notebook, and it's exactly what we are going to do. So I will try to replicate, but I will run, you know, a few scenarios that are maybe different, or maybe if you have questions, we can try a few things live. So let me just share my screen. And I'm going to share first the Github repository. Okay, so the Github repository, or GitHub, is a, you know, it's a place where we can place code and data, and then, you know, other people can access this code and, you know, download it, make changes, and upload it back to our GitHub, and then, you know, the person that is the owner of that repository can then accept or reject changes. So it's a really great tool for collaborative coding. It's widely used in industry and research, and I think it was bought by Microsoft by like $9 billion. So pretty pretty central to to today's infrastructure related to coding. What you can do is you can actually go to the green button code, click there, and if you know how to use GitHub, you can actually clone it, which is a specific word or the same as saying to copy the code. You just need to use some terminal commands. And if you don't know anything about GitHub, you can just download the zip file and then uncompress it and open the content there. So either way will work. So we are not going to cover how to use GitHub. I do teach a class in reproducible research and scientific computing using Python, where we learn how to use GitHub. Then there is a semester project that you have to do, and you have to upload it here, and then share it with the rest of the class. So if you're interested in learning how to use GitHub and Python, consider maybe taking that class. And I'm not sure if there are other professors in our department that use GitHub, but it's a pretty interesting tool, and certainly something that if you're looking for a job interview, if you say that you know how to code and you know how to use some of these industry standard tools, it could give you an edge on the interview. Okay, now let me just share pandas. Sorry, Anaconda. So many names. Okay, now you should be looking at the Anaconda Navigator, which is, if you go to the search in Windows, if you go to search, you just write Anaconda, and this is what it will open. So there are tons of applications and things that we can use to code in Python. Even I believe you can have or install RStudio for those that are familiar with R. When you actually, it's right here, I have it. I don't use it much, but you can also code in R. And so what we are going to be using today is called this Jupyter Lab, which is the new version of something called Jupyter Notebooks, which is just right next to it. So we're going to launch Jupyter Lab. Now something should be opening that appears in a different screen. So I need to change screens. But something that I want to comment here is there is another a development environment called Spider, which stands for Scientific Python Development Environment. And it has some advantages over the Jupyter Lab. And of course, Jupyter Lab has some advantages of Spider. But this is another very popular environment to code in Python. So in case you maybe I know that some other classes in our department use the Spider IDE. So either one is fine. They just serve slightly different purposes. But I really like the Jupyter Labs because it creates like a document step by step, and it's really good for teaching and for learning. So let me just bring my, okay. So there's so many screens now. Okay, so now you should be looking at the Jupyter Lab, and it will open right there. So now you need to navigate wherever you want to save the content of today. You can create a folder, you can create a file right here. So what I'm going to do, I'm going to navigate where I have some of the content for the workshop, but you can just navigate wherever you want. Do not create a Python environment yet, okay? So let's just navigate for wherever you want to create that environment. So I'm gonna go to my Dropbox. I am going to go to my, and I'm gonna go to the Python workshop. So here is going to be my folder. So I have day 1. And I go there. And once you're in the folder that you want to work, just go to Python. See, it says create a new notebook. You can create a Python 3 right there. Okay, and automatically we'll assign these untitled IPython notebook extensions, IPy, Y, and B. And that actually is very good because even if you forget to save it or to to give a name, it will keep saving, at least in this untitled notebook. Unlike other programs that if you don't save it, if you don't assign a name, and and your computer crash, you lose all the content, the Jupyter Lab will keep saving here. So I want to do a right click, I'm going to do rename, and I'm going to just write live demo. In here, you can assign whatever name you want. Okay, so that's how we create our notebook right here. That's where we are going to write the code. But it's not just code. We can actually have text, we can have figures, we can have tables. So, and that is why it becomes so powerful. Okay. Now, before I start writing code, let me just go to the few things about the today's workshop. You can actually hide it here if you want. You just click on that folder and it will hide it. Okay. So the goal today is to have a very simple, pipeline or workflow on how to load some tabular data, how to inspect the data, how to replace some missing values, how to select specific data, how to make some computations. We are going to use some weather data from the Kansas Mesonet to compute thermal units. I believe that is fairly standard. Everyone can relate to that. One of the challenges of this workshop is that the audience is very broad, so trying to keep everyone happy was probably the main challenge that I had. But I think thermal units is something that we all relate from one point or another, or at least we are familiar with. So that's the goal today. And if we get time, we are going to actually implement a very simple, biomass model for winter wheat, and using that thermal units that we compute in this example. So one thing that I want to clarify, because I know that many of you are using other software, SAS or R. Perhaps this is the only advice that I want to give everyone is, it's great that you're trying to learn, and I highly encourage you to keep learning how to code. One thing that I advise you against is trying to learn many different languages at the same time when you are, you're a beginner, when you're starting to learn. Even I know that sometimes it looks good to have in the CV that you have, few that you know how to use maybe multiple languages, but the idea is to maybe pick one and learn it well, learn the basics, then you can jump into another language, because sometimes the mechanics, the logic is very similar. But make sure you learn one. It doesn't matter which one. You can learn R, Python, MATLAB, Julia, whatever the case is. Just focus on one at the beginning. Okay, so we already have some questions. The lab will be opening in a browser. So in my case, it opens in Chrome by default. You might try to open in Explorer in some other computers. And if you have Explorer as your default browser, or Edge, you might want to set it up to Chrome. Okay. So let me just quickly. Perfect. So one thing that you want to do now is we are going to be writing some code. These comments I will not be writing. These are in the Jupyter Lab notebook that you can read later. One thing about Python is that it really pays attention to white space, to indentation. The language was developed with the with the goal of being readable, human readable. And the idea is that sometimes the code is read more times, but no coding, but just reading the code to see what it says, to debug, and to learn from code. And so this is something that is upfront in how we write Python. So I will be emphasizing a lot this issue of white space. Okay, but let's just try and start doing something, because otherwise it's hard to remember all this stuff. So if you can get the chance to do it, it might be easier. So the first thing that we are going to do is learn how to write a comment so that we can comment our code. So we are going to use the # like that, and we are going to create something very basic at this point. So let's just write a calculator example. Okay, that's just the title of our cell. And now we are just going to do a very basic example on how to use Python as a regular calculator without having to import any module, without having to do any plotting. It's just, very simple so that you get familiar with, how to define a variable and how to do simple math. Okay. So for that, we are going to define, let's say, the soil temperature. We are going to write this as to be 56, but here we don't know what this is. Because it could be Celsius, it could be Fahrenheit. We can add a comment right here. We just write it here in Fahrenheit. So we indicate with another comment the units of this temperature. Another option that we have is to actually make this part of the variable. So we can do this, right? Or you can write the entire word. I want to just write it like this. And now the goal is to convert this into Celsius. So how do we do that? Soil temperature. Celsius, and now we need to apply the formula for that. So which will be the soil temperature. And here I don't, I'm getting tired of writing all this much. So I'm going to write a few letters like this, and then I'm going to press the key, the tab key. Okay. And that is the auto completion. And then I'm going to choose the one that matches, which is the Fahrenheit. That's the one I want. So I'm going to click enter. That, that way you reduce the chance of, introducing a typo. And now we subtract 32, and then we do this times 5/9. And then when we have the answer, we can print. Let's just actually run this. So you can do Control Enter if you're in Windows. You can do, I believe it's Command Enter if it's in Mac, and it should run it. Nothing displays, but we didn't get any error. Okay. So now, how do we see the answer to this? Well, we can do a few things. First, we can just type the variable here for Celsius, and we run it again, and we get the value there. That's one option. The other option, which is widely used, is the print function. So we surround the variable with parentheses like this. We write print, and then that will print the number. Okay. So we can actually use the print command to make it a little better. So we can actually pass a string, which is text. Okay. That will be, let's just write hello world. If you have never done your hello world, then this is your chance. The typo there, hello world. And then we can say, today the soil temperature is like that. I'm going to place a comma. I close the string right there. Place a comma to separate because I'm going to pass another argument to this function, which is the soil temperature in Celsius. And then I'm going to keep with my string or with my text. I'm going to say here Celsius. Okay, and then I'm going to write. Okay, so that's a nice way. Now the number is a little ugly, right? So maybe we can just have one or two decimals. So let's use the round function, round. And then we are going to pass here 2 decimals. And I'm going to slow down a little bit and explain all the things that we are doing. Okay. There you go. That's a very simple example on how to use Python as a calculator for anything. So let's go and revise some of the components or the elements that we have here. The first thing that we have here is a variable. And this is called a variable, and it holds, in this case, a value which is called 56. We then define another variable, soil temperature, where we convert or we store the result of our conversion right here. Okay. So what happens is if we don't do this, if we do just like this, let me just delete it for a second. You don't have to do it. But if we do this, let me just keep the parentheses, the computation here will happen anyways. The problem is that we are not storing the result into a little container, right? And so then when we want to use it here, we can't. Let me restart the kernel and you will see what happens. So you can go here and restart the kernel, clear all the outputs, and that will reset your Python environment. Okay. let's just do that. Now, if I run this, when I call the variable here, because it doesn't exist, it will tell me that I don't have it, okay? So that is what we do variable names, or what we define variables. It's just so that we can store information that we can use later. Okay? Anyway, if you were completely new to programming, this at least should give you some idea on the basic concepts. There is more, but at least here we cover a few types. Let's do the type of this one. What is this? So let's do type, and let's do Fahrenheit, and that gives that it's an integer. See, so Python recognizes this as 56 and not as 56.0. So if we really want to denote this as a decimal, or as a temperature that could have decimal places, then we need to define it like this, 56.0. So if we run this again and we run type again, now you see that it's type float. Okay. And then we have a few other things. So this part here is called a string, which is really text. This here is called a function, and that has some input arguments. This will be one input, which is the variable that we want to round. And then it has a second input, which is the number of decimals that we want to round it to. Okay. Someone doesn't have the result on the screen. I'm not sure exactly what that means. Can you use the print function? That would be one option. The other one. Okay, there you go. So yeah, you need to. So good point. For the results to occur, or for the Python interpreter to run the code line by line, it's important that we run the cell. So it could be the Shift Enter, and you see that there's a number here that changes. That means it's is running. And then, or if you want, you can do in Windows, I believe it's Shift Enter, and it will run it and it will create a new one. Yeah, look at that. See, if I run it, it creates another one. That's Shift Enter. If you are in Mac, I also believe it's either Shift Command Enter or Shift Enter. Anyway, just explore with the just search for the shortcuts. They are not super critical, but it might make it really handy if you want to go cell by cell. Okay, so hopefully that was sufficient to get you started. Now we've been defining variables here. So we have salt temperature in Fahrenheit, salt temperatures in Celsius. And so one thing that we can try to do is to use this notation in the Jupyter Lab. So I'm going to say print all variables in the workspace. You can use this notation of the % symbol and then type whos. And that will tell you all the variables that we define so far. In other words, these variables that we just defined, they are in memory, okay? And as we go through the notebook, we are going to be defining more and more variables. And these variables, they have to be in memory. They hold that value somewhere in your computer. So with the whos command, we can actually see not only the names, but also the type of each variable and the value, the values that they have, or maybe the ranges of the value. At least you can see a little bit what is that we already created in our environment. Okay, so that might come handy later. So all of this was just a little bit of a playground to test a few things. So now we are going to diving into importing our data and dealing with the topic of the day. Hopefully this example at least gave you some rough idea on how to get started. So we're going to create another cell. Either you can insert that cell here with the plus sign. And now we are going to do another interesting thing. You can actually move these cells, right? So you can move it to the top. And one thing that we can do is see that it says code. We can actually go here and use Markdown, which is a way of documenting our notebook. And then we can actually use some of the Markdown notation. So if you use the pound sign here, that will be a comment, and that will be ignored by the Python interpreter. But if we use the same thing in Markdown, then that means that we are adding a title of first order. So Python workshop. Then when I press Control Enter, now that becomes a title. Okay, and we can even add more text. So all this entire cell that we have here, it will hold text. And text, not just plain text, but we can actually format this text by using a specific syntax, which is called, again, Markdown. And there are different or slightly different ways of giving or syntactical ways of assigning format to the text. I think there is one called R Markdown. There is the one that we are using now. I think it's called the GitHub Markdown, and different languages have adopted slightly different version just to adapt it to their own ecosystem. But overall, I think the main features should work across different platforms. So Python workshop, this was a simple test to get us started. Okay, and then when I do that, I have some text here. Okay, we're gonna add one more, and now we are going to do. We're gonna get Markdown. We're gonna insert another one called import modules. Or you know what? Let's just do it exercise. Thermal units exercise. Let's just call it like that. So you can see that I'm deviating from the template. I usually don't like to follow exactly because that's boring. So as I'm typing, I'm thinking on a few things that might be interesting, and we can play a little more rather than just following the notebook that is already done. So we're gonna do that. And now we are going to do load or import modules. That's the first thing that we had to do. So maybe I need to explain what a module is quickly. So see that here we were able to write some Python code. We didn't need to, call anything. We just wrote, and it did work. If we want to, let's say, load some data or create a chart or something like that, then we need to use additional code that is not included in the standard or in the core Python language. Okay, so in other words, other people, developers, they wrote the code that will transform data into plots, and they made that code available through something called a module, or called a library, or in other languages called a toolbox. And so we can actually install, download and install all those modules and make use of them. Many of them are free and available to the community. But the good thing about Anaconda is that it already compiles or has many of these modules already installed. So when you install Anaconda, you install hundreds of these modules that will get you started. And that's why Anaconda is so popular. But it doesn't have all the modules, so you can actually go and install additional modules that do not come with Anaconda. So we need to import some modules to load some of the data for today. If you open the folder, you will see that there is a file called Ashland Bottoms 2019-2020. It's a CSV file. I downloaded this data from the Kansas Mesonet, and so we are going to be using this file. You can also double click here, and the Jupyter Lab will already show you. So you don't have to go back to Excel, and you can actually take a look at the tabular data right here in the Jupyter Lab. You see that at the beginning there is a line which is not showing very well, and that is because there is a comment. There is a comment. You can need to go and open this in Excel. There is a one line at the beginning that I added to, just to attribute this to the Kansas Mesonet. So we need to learn, read this table and somehow maybe skip this line that, is simply for documenting purposes. Okay, I'm gonna hide this again. And now we can start. So we are gonna import a module called pandas. Import pandas. But to avoid typing pandas all the time, we are going to give this an alias. So basically a shorter name. So we say as PD. And here I'm using the common notation or syntax in the documentation, which is always the recommended way to go. But you can, you can just give your name here, and then every time you call pandas, you actually will call it your own name, okay? Okay, so we are gonna do that, and we are going to add a few more modules. But here is something that happens. You want to do something, you probably look at online for a tutorial, and the tutorial has, in this part, 7 or 8 different modules, for loading data, for plotting, and it becomes overwhelming, right? Because the code never starts like this. So we don't typically import too many modules at the beginning. So what you see in a tutorial that is already online is the final version of the tutorial, but maybe it's not how it started. So I want to come here to this cell where we're going to import the modules, and I want to add the modules as we go, okay? So we're gonna import this one. We are gonna need more modules in the future. But I'm gonna run it. Okay. And now we have pandas there. So what do we need to do now? We need to load the tabular data. So let's actually create another cell, load tabular data. And hopefully you see what we are doing. We are working in cells. We are adding very little code in each cell. And the goal here is to make sure that before we move into the next step, that the previous one is running and is doing what it should be doing, okay? So this is really nice because we can break down the entire problem of doing this computation of thermal units into smaller chunks or smaller problems that are easier to solve, okay? And programming is a lot about that. It's about breaking down problems. And so that's why I like a lot the Jupyter Lab. Okay, so how do we load this? So we need to assign a name where we want to store this table. Basically, we want to store this, but in Python. So right now, this is not in Python. We just did double click, and this is showing sort of a, just for display purposes, but we cannot use this data at this point. So we're gonna do the following. We're gonna use df, and if you're an R programmer, that probably, this stands for data frame, okay? So it's the same thing. So we're gonna use pandas, we're gonna call the module, and here we are gonna add a period, and then the tab key. And here you can see all the functions that are available within this module, okay? It's very large, it's one of the most popular modules. And something that, just to maybe simplify that, type read and underscore, and then press the tab key again. So now it's going to filter for only the methods that, or functions that start with read. We are going to use one called read CSV, but you also have read Excel, you have read JSON, read HTML, read SAS. I didn't even know that. SPSS. Okay, so you can read all sorts of stuff with this read table, but we're going to use the read CSV. And now we're going to open parentheses. So every time that we open parentheses, that means that we are invoking a function. Now the catch is that we need to know what are we going to pass inside of this function, right? Because there are some arguments that we need to give so that the code behind the scenes can actually read that. So basically a function works like this. It's argument 1, argument 2. Sometimes you need 1, sometimes you need 2, sometimes you need more of them. But we need to tell what are the inputs. These are the inputs. This is the name, and this is the output, okay? So when you type, for instance, something like this, y equals x squared, right? This is an exponential function. X is the input, and y is the output. So that's what we call this a function, right? We have inputs, and then we get outputs. So there is something in the middle that is doing this number crunching of that process. Okay, I'm gonna delete that because that's not gonna run. So we need to know what are we going to pass here. So before we go too far, I want to show you, or I'm not sure if my screen will remain live, but just open another tab in your browser and just search for pandas Python. I'm not sure if you can still see it or not, but once you get there, go to a API reference. once you're in pandas, then you can search for read CSV. If you cannot see my screen, please let me know. I assume that you can. And then you can click on pandas read CSV here. Okay. So these are all the input arguments that we can pass into pandas. The first one, or the one that we know, is the file path. So where is our file located? And after that, we can give it lots of options just to handle, I don't know, comments or different, maybe the data is not comma separated, maybe tab separated or delimited. We can try to infer, other things. So we can specify, according to the complexity of our data set, different parameters so that we can handle the data. We can read it in the format that we want it. In other words, we can make Python to do all this heavy lifting before we get to see the data, so that then it's easier to work with. Okay, let me go back. So the first thing that we need is the file name, and here we have it. It's Ashland Bottoms 2019. So I'm going to open. This is a string, right? So this is text. So we are going to open. We're going to do the apostrophes, and then I'm going to start typing Ashland. But I don't really want to type all, and I also don't want to make a mistake. So I'm going to also use the tab auto-completion. And that's all. Okay, very simple. Try to use tab auto-completion as much as you can so that you reduce the chances of introducing a typo. We have that, and now we can run it, and it's very quick, but we don't see anything. So how do we see that? So pandas data frames, they have a specific function called head or tail. In this case, we call the function empty. If we pass this empty, there are some default values for how many rows is going to display. And the default is 5. So here you have it. By default, it's showing 5. We can actually type any number that we want here. We can type 10, and then we're going to get the first 10 rows. We can type 3, and we're going to get the top 3. This is usually useful to see not only the column names, but also a little bit of the data that we have. You can also use the function tail. And now you can see the last 3. Yeah? So you can see that we have 732 rows. And now I'm going to explain why 732. Let me just put it back to that. Sorry, to the head. Okay. And we have 732 because we start in 0. So Python is 0 index. That means that the first element of an array of pandas, it will start with the number 0. And that's how we access the first element. That might seem a little counterintuitive if you're just learning how to code. Many languages do this. Other languages are 1 indexed. So that's just a preference of the developers of the language. Okay, now we have this, but we see that something is not right. We have a name, column header, so something is not right here. And I suspect that is because we have this comment line that the computer is trying to read that as a header. So we are going to use the comment option or parameter, and we are going to specify what we are using for a comment, which is the pound key, the pound sign. And now once I do that, Python is going to ignore all the lines that have that pound sign. Okay. So now you see that everything is fixed. And now we can see all the columns that we want. These are all the columns that we have. So we are going to move into another one. And I'm going to show you can actually type df columns. And that will print all the columns that we have. You also see that there is a word here that says object. And in Python, pretty much everything is an object. And objects have specific properties and specific functions that allow us to process the data or to access the properties in that object. Okay, so we can actually find out what kind of object that pandas is. Let me just do this column here again. Let's move to another. I want to show you something. You can do type. Remember that we did type earlier for doing what salt temperature was. So we can also do type df. You see that this is a pandas core frame, which is basically a data frame. Okay? Anyway, you can check that for pretty much anything. Okay, so now we have our data right here. So what else can we do now? Well, I read it from the file, and that is assuming that you have it in your file. But you can actually go to GitHub, and maybe let me see if I can switch. I can switch screens. I'm going to start moving a little faster as you get the point. So hopefully now you see my GitHub. So you can go to day 1. You can go to Ashland Bottoms right here. And now you can see the data. Now you cannot read this like this, but you can go to raw. And now you see the text that is in comma separated values right here. So now you can grab that URL, copy that. I'm going to stop sharing that one. And I'm going to back to my and hopefully I can find the view. Okay, so now we can go there and we can actually replace this with that URL. In fact, to make it a little more organized, I'm going to create another variable called URL. I'm going to paste that. And now instead of having this, I'm going to remove that file name. I'm going to call it URL. Basically, I'm passing this content into here. So I can run this again. And now we get the same exact data frame in our screen, but it's coming from a complete different place. Okay, this is reading the same file that is online. And this is kind of neat because now you don't need any of the files. And that's what I sent all the files a little too late today because I didn't think that you actually needed to have this. You can either follow everything through GitHub or just copy the URL. So this is kind of interesting that, or it will make things much more portable without having to download a ton of data. Okay, so now we have this, and now we can keep going a little more. So we have, the first thing that we have here is a date, so timestamp. We have dates. And the pandas data frame is column oriented. So every column is a variable, and every row will be an entry, in this case, a day. And then that's usually how it works. You can also assign names to the rows, but usually we work as column-oriented data structure. Okay, so the first thing that we have to do is to convert this timestamp into date. And now you might think, okay, it's already a date. What else are you going to do? Well, this actually, let's see if we can check this. We can do df, and to access the specific column, we can actually open brackets, open the apostrophes there, and type time. And if you do it in uppercase and then you press tab, it will autocomplete the variable. So you have timestamp. Okay, and now we can Control Enter, and that's going to print everything that we have here. Yeah, that's one option. We can also access the first element. So basically here, this one returns the entire column. But we can also access each element of the column. So we can do this, 0, and now we can access. And now we access the very first element. Now we can do type. Of course, you don't do this every time. You already know that some of these things are already in this format, but I really want to show you at least some of the basics at the beginning. And see, when I do type of this first element right here, I get that it's a string. And a string looks like a date, but the computer does not interpret that as a date. So what we need to do is to tell the computer that this is a date of specific formats. So for instance, the computer doesn't know now whether 2019 is a year or not, and let alone knowing whether one is January or a day. Is this January 1st? Sorry, 1st of February 2019 or January 2nd of 2019, right? So we need to tell the computer what the order is. So let's do that. So I want to eliminate, well, let me see. Let me just comment this. I'm going to leave it here, and I'm going to upload this to GitHub. So check type step. Okay. So what we are going to do now is overwrite this column. So we're going to do df timestamp equals, and now we need to convert this to a date. To do that, we are going to use a specific function or method in pandas data frame. So we're going to do pandas dot to datetime, again, up to completion. Note here that I'm not calling the data frame. This is a method or a function that is available here. It's available in the main module. It's not available on the data frame. It's not the same as df.head. Just note that difference there. So we need to pass what we want to convert. So that will be the df timestamp. Okay, so it's the same. And then we need to tell what is the format. So format, and here we need to use some specific syntax. And I'm going to explain quickly, but you can go to the other notebook that I share in GitHub, and you can see some of the details on what they mean. So we need to define what this is. So I know that the first component here, that will be month. So we need to tell that this is a month. And so for doing that, we're going to use the % and the lowercase m. That tells that is a string in the form of month. That's going to be the input. Then we have a // that's part of the date. And then we are going to tell that the second part is a day. And then we do a // and then the third part will be a year. In this case, it's a year with 4 digits. So that is uppercase Y. Okay. And that should do it.
Dr. Andres?
Yes.
Did you increase the font?
Will that work?
Now, yeah.
Okay, awesome. Thank you. Oh, actually, for those that are planning to maybe at some point give a presentation, I believe you can go to view, and there is one thing that's called presentation mode. It apparently didn't change very much, but I'm going to keep running presentation mode and see if that makes a difference. Okay, so now that ran, and we didn't see anything. So, but we need to check our work. We always need to check our work because we don't want to be. Let me just get out. We don't want to keep going with our work without knowing whether we did the right thing, the right conversion. In other words, the fact that the computer did not give an error doesn't mean that everything went fine. It means that we wrote some valid code, but we don't know whether the computer did what we were expecting it to do. So let's do that, do head again, and let's print. And now we see that the dates appear in the right form. Okay? Now Python knows that these are dates and they encode some information. We can, in fact, copy this again, paste it here, and we can check again. And now you can see that this is an object of, timestamp. So that means that that changed. Of course, if I run this cell again, don't do it because that's going to change. It's going to, conflict with the flow that you have. But if you run this again here, this string will change to this because now this part is referring to this new data frame that we just changed, right? So we are overriding here. So if you run this one, it will no longer print string. Okay. So we have that. Perfect. Let's move on. What else do we need to do? We need to check whether we have any missing values. And so we are going to be using, we are going to compute thermal units. So that means that we need temperature, minimum temperature and maximum temperature. We need to compute average temperature with these two. So, we might have some missing values here. We don't know. So let's see if we can check this. Here I want to show you something really cool in Python that's called Booleans. So we can do df, and there is a method already called isNA, which actually checks for something called nans. Let's see if I can check for missing values represented as nans, which stands for not a number. Okay? That is how Python represents missing values by default. I think in SAS you place a dot. Different languages have this. Other languages like MATLAB use the same thing. I believe R uses maybe NA. Someone correct me, please. But different languages use different placeholders for missing data. So we can do this, and now we get all these table or matrix with false. We don't get to see everything by the Jupyter Allow automatically restricts so that you don't have, imagine you have a few million rows, you don't want to have that in your notebook. But this actually means that it's checking whether each value is a NaN or not. And if yes, it will show true. And if not, it will show false. And it does that for every single element. Now, because we have, several columns, and because we have 730 something, rows, it's really hard. We don't want to inspect this. So we want to find another way of at least checking how many we have. So false technically represents false is 0 equals to 0, and true equals to 1, right? That's the binary. So we can actually take advantage of that and do a sum for each column of all the, all the false and trues that we have in here. So let's do that. So we can do df is NA. And that will, if we run this, we are going to get the same result. But one of the nice things, well, it depends. Some people like it, some people don't like it. But you can chain different functions. And I'm going to explain what this means. So we can do sum, right? So we can do this. And now you have the total sum for each column for the ones that were missing, or that the ones that resulted true. So we see that for minimum temperature, we have 4 values, and for maximum temperature, we have 4 values. So that's how we can check how many we have. So, but let's see what happens here. So we have all of these, and it's hard to keep track of the order of the execution here. So what is Python doing exactly? Python is for executing this part. It's grabbing the data frame, then it's applying for each element, for each cell of the data frame, it's applying this function and checking whether that is a NaN or not. If yes, it's gonna place a true, and if not, it's going to assign that cell a false. Once it finishes with everything, it then executes the sum. And the sum is by default done column-wise, because usually this is how people use it. So when you run sum here, it's collecting the sum of all the true values here, the sum of all these here, and so forth and so on. And that's what you see here. Okay, so that's why we get this here. So we can say count missing values. Okay. So once we know that if we didn't have any missing values in the 2 variables that we need, we can probably just keep going. But now we need to make a decision. Do we keep those missing values and trying to handle everything, or do we try to replace the missing values? And here is where the language cannot give you the solution. You need to use your own statistical knowledge, agronomic knowledge, and find out whether it was worth replacing those values or not. I think because minimum and maximum temperature, they have a fairly well-defined dynamic, and probably these 4 values are not all together. Even if they are all together, maybe it's not that big of an error if we replace them. So in this case, I'm going to show you how to replace the missing values. But I deal with this a lot in my classes. Sometimes you don't have to replace. Sometimes you just need to keep going. And you can make many of these operations like summing or taking the average or whatever the case is. And many of the functions will actually ignore these missing values. So it's not that you must replace them. Sometimes you can, just to be more transparent in your data set, in your analysis, you can actually keep them. And it's fine to have a line plot or a time series in your paper that shows a little gap, showing that there was missing value there. And at least for what we do in our lab, that happens a lot. We work with instruments in the field, and sometimes they don't work as expected, and we lose few days. And it's just fine to show that for a week or so, the battery ran out of juice, and then we didn't collect any data. So let's see if we can learn how to interpolate that. So we'll replace the missing values. So interpolate values. And here is where, again, Python has some really neat tools in pandas. So we can do, first of all, we can do the following. I'm not going to run this, but I want you to see what you could do. Interpolate. And here you can just do this. I'm going to do this in place true. So that you can do this. And Python is going to interpolate all of these variables using a linear method. And again, how do I know that? Well, if you go to the documentation, if you go to interpolate, then you will find here that it says method equal linear. That means that when we don't assign anything, the method will be by default linear. And there are other methods below that we are going to use. But you can just do that and it will do the replacement of the missing values for the entire data frame. So if linear is fine and all of this, that could work. But in some cases, you want to maybe interpolate different variables with different methods. For instance, sometimes if precipitation maybe is not worth to be interpolated, sometimes you may want to assign a 0 or just to work with the missing values. You may not want to touch that one. So, but let's do 2 individual interpolations so you know how to do that in case you get to do that for your research. So we're going to do temp. Let's start with temp mean. And now we are going to do interpolate. And now we are going to specify the method that we want. And I'm going to use it's called pchip, which is a piecewise cubic interpolant. It's fairly strong. And then we can also do, we can limit the scope. So in this case will be, if we have values on the extremes of our data frame, that will be an extrapolation. In other words, it says that it has values on one side of that missing value, but it doesn't have on the other. So it has to do an extrapolation from the last known value. Sometimes that tends to produce unrealistic points or values. And so we want to sometimes restrict that to only interpolate data if we have values, known values in both sides of that missing value. So that's what I'm doing here. And the in place true, what it's doing is see that we are not defining, we are not doing this. We are not doing that, right? You can do that, but we are not doing that. So what we need to tell is that once it finishes replacing the missing values to replace that into this one, okay? To override it basically. And true needs to be uppercase. So we do that, and let's do the same with the maximum temperature. I'm just going to, okay. And here you can change, something different. You can choose a schema, you can choose linear, you can choose polynomial, you can choose whatever you want. I don't think it's gonna make a dent, to be honest, if we use a different one here, but I'm gonna just keep the same. Okay, I think, oh, I made a mistake. Oh, method, there we go. There we go. So now again, we need to check our work. And we are going to run the same as we had here. Again, I don't want to rerun this cell because we are going to erase the output because again, it's going to show maybe all zeros, at least for the temperature. So I want to keep that as part of the exercise. So we're going to do that again. And now you see that we replace effectively the minimum and the maximum temperature. Okay, we didn't replace the other ones because we didn't do that. So, okay, so I think we went too far without without looking at the data. It's like we've been looking everything in tabular mode, but this is the point where we need to stop a little bit and we need to start plotting our data. I will even encourage you at the beginning when you just load the data to try to make a figure just to see. Maybe some of the data is not represented as nans. Maybe something is represented as -999, and you see a spike, in your data set. So you want to have a little more intuition what's going on. So we're going to plot the data now, but feel free to, for your research to start plotting much earlier. Okay, so now what we need to do is so if we want to create a plot, now we need a different library. So Pandas has some plotting functions just to get it really quick, but I want to show you a few other libraries that are more interactive and probably a little easier to use. So let's go up. We are going to do import modules, and here's where we're going to add another library. So we're going to do import, we're going to do from bokeh plotting. And we're going to use a library called bokeh that it has a submodule called plotting. That one has another module inside. That is the figure, the show, and we need to import a special function node. And you can also use the auto-completion here. Output notebook. There you go. And this will actually allow us to see the figures in the notebook, and they will be interactive in the notebook. So I'm going to call that function output notebook here with parentheses. Make sure you put the parentheses when you call the function and not here. So don't do this. Don't do that. If you run this Control Enter, then you should see that bokeh was loaded, and that's when you know that everything went fine. Okay, I'm going to keep this a second. Okay, so figure, show, and output notebook. That's all you need. Let me go down. And now we are going to create our first plot. So we're going to create a figure. So we're going to call this figure 1, and we're going to give just a figure like this. Again, what you see in the template that I showed in GitHub is the final version. What we want to make sure now is that we can get the values in the screen. After that, we are going to add, few more properties, but let's not get ahead of ourselves. So we're going to do figure, and then we are going to do, so that is going to be an object, right? This F1 is going to be a figure object. And now we can pass, we can create a line. So a line is a method of that object. And then here, there are different ways of doing it. I'm going to do it. I'm going to be consistent throughout the tutorial, but I'm going to show you two things because I know that depending on the language that you use, you might be used to one or the other. So you can do it like this first. This will be more like X, Y kind of approach, and then properties. Okay, that's one option. So I'm going to first define my X, which is the timestamp, then comma, space, and now I'm going to define my temperature. So I'm going to call temperature, let's say minimum temperature. Okay, and now we are going to do show F1, and here we have it. Now it's not that, it's pretty already in the sense that there is some, some things that are interactive here. You can just pan in, you can zoom, you can save it, you can restore it. So it's already interactive. But you can see that the timestamp is not rendering well. We don't have labels. The axis, the shape of the aspect ratio of the plot is not the best. So let's see if we can start figuring or fixing this. So the first thing we have to fix is the time, the x-axis. So we are going to use the x-axis type. He's going to have to complete. Apparently no. Okay, and we are going to use date time here. And then before I keep going, I want to run it again. I just want to see if the issue was fixed, and indeed it was fixed. Okay, so that's the first thing that we want to do, is one step at a time. We are going to fix now the plot. So we're going to do plot width, and we are going to assign this, I don't know, 600 by a plot height. We're going to do this by 400. Maybe that will make it a little nicer. You can, for time series, you can have it a little elongated. There you go. So you can actually see more detail. And what else do we need to do now? We need to maybe add another line here. So let's do timestamp will be still the X. And now we can do here the maximum temperature. There we go. So now we have two lines, but we have a problem because they both have the same color. So one thing that we can do is to add a specific name. Okay. We can add a name. This will be called tmin. and we are going to add this color. So tmean will be cold, so that's usually maybe blue. You can say blue or some other name. And then here you can do again, we're going to use name tmax. Color, you can say red. Now we have it. Now blue and red are usually not recommended, but just to give you an idea. So we are going to change this for navy, and we are going to change the red for tomato. It's a little less brighter. Okay, so we have that, and we can also add a title. The title will go into the figure. So here we can go and do title, and we can have Ashland bottoms weather. Have it, it's up here right here, and you can change any aspect here. Let me show you. Let's just go to Bokeh quickly. Bokeh Python, and so Bokeh, it allows you to do apps in the notebook. It's pretty neat, and then you can go to the tutorials or to the demos, and here you have. In fact, they just changed the website, and now you say if you're new to Bokeh, then go to this place. If you're more advanced, go to the other one. So I really like this library. It's still under development, so it's not as advanced as something like ggplot, for instance, in R. But it's pretty nice. So here you can check for all these features or all these plots that you want to do. You can do to tutorials, and you can learn how to adjust the different variables here. The only way to learn this is by just looking at the documentation. So any programmer, spends as much time in the documentation or even more as in front of the coding environment. That's just, and usually try to focus or to go first to the official documentation, then start, searching in Google or Stack Overflow or some other websites for how to do something very specific. But I highly recommend that you first go to the official documentation and look at the definitions or the properties and the examples that they provide. Okay, so now we have that. We need to add maybe some, we're not gonna add an x-axis label because I think it's self-explanatory that this is a date. So we are gonna add a y-axis, and so y-axis. So we access the y-axis of the figure like this, and then inside there are properties of this y-axis that we want to change. So axis label is one of them, and then we are going to do air temperature. I just see that there is a typo in there. So air temperature, Celsius. Now we have it right here. Okay, you can remove the toolbar, you can hide some of these things, you can add a few more, you can add tooltips, you can put this at the top, at the bottom, you can all sorts of stuff. So, but now we have it here. At least it looks reasonable, right? So that's what we want to check. Right now we are not super concerned about this. We can always come back and keep making better, but the scope was to visualize our data and see if there is something that looks, out of place. Everything looks fine. And now let's keep going. Okay, so now we need to start doing something because we have 2 years here from 2019 to to the end of 2020. So the goal now is to do something for winter wheat. So we are going to assume that the winter wheat was planted, in October of 2019, and then that it was harvested in June of next year. So for that, we are going to sort of do something like this. I don't know what October is here. Do something like that. So we are going to be using that data. So we need to select that, and then we need to do something with it. So let's see if we can do that. I see something in the chat. I already see that it's already 5:10. So I will try to collect the comments in the chat and either answer you, via email or trying to add your comment into the notebook that is in GitHub, if you don't mind, so that we can move a little faster. Okay, see if you. Okay, perfect. So what are we going to do now? We need, so let's just define our growing season. Growing season. There we go. Growing season. So we are going to call this planting date. You can call it start date, and we are going to define it. So it's going to be 15 October 2019. So if we place it like this, it's going to be a string. And again, Python will not know what to do when we pass this, right? So we need to tell Python that we are going to filter this. So what we're going to do is do the pandas to datetime. We are going to convert this on the fly, right? So we are going to convert that, and we are going to pass the format already. So what is the format that we have here? We have, the first is going to be a day, and we need that. This is a string. Then we have a dash, so we don't have a forward slash in this case. We have a dash. Then we have a month, but it's not M, because in this case it's B, because we are representing the month with 3 letters. So that will be B dash, and now we need a full year one more time. So that will be the format for what we need to do. And hopefully that works. Let me see if we can check, and then we are going to do the other one, planting date. And there is a typo there. There we go. So it's a timestamp, and it's exactly what we wanted. So now let's remove this. So when you're checking, you don't have to leave everything here. It's just for you to know that you're moving safe, to the next step. So we're going to call this harvest date, and we are going to do, I don't remember what I said, maybe 1st of June. There you go. And now we can have that. We can also do some math with the dates. So once Python knows the dates, we can actually do some math. So we can actually do growing season length, and we can do duration, and we can do harvest date minus planting date. And let's see what we get here, growing season. So we get a time delta object that it says minus 136 days. So that tells you that I made a mistake already. And because this one should be 2020. There you go. Maybe someone in the chat was trying to tell me that. So once we fix that, now we get that this is 230 days. Okay. So or Python already understands that when we do the difference between dates, maybe we want it in this format. But we can actually even specify what is the format that we want. So we can actually say days here, and we can get the number in days. Before we were getting the object, right? That's an object, that's a time delta object. But here we can just access that specific property and get the days. We can also get other things. So you can do tab and see everything that is actually available to you. Well, it's not working in mine. But you can do total seconds, for instance. And that's a function, okay? So that says there is a function, so we need to add the parentheses, and that tells you the total number of seconds from planting to harvest. Of course, that might not be as handy as dates, so we're gonna use dates. And you can print, you can make this a little more interactive, a little more of a formal document. So if you have this, you can then just do print, and then you can do planting date, comma, and then pass the planting date. And here maybe there is something that it will be nice to realize is that when we do this, see we have planting date here and planting date here. They are different. This is a string, it's just text, and this is, we are calling the content inside of this variable, which is this. Yeah. So I also omitted to mention that this actually we need to add one day here. And the reason is it goes from midnight to midnight. So if we harvested, if we harvested the crop, it probably happened on that day. So it's considering to the day before on the June 1st, right? So we are missing one day in this computation. So 15 October is considered the entire day because there's a midnight and it goes all the day. But for this one, we don't really get it. We just get it to that midnight. So we need to add one to make it, square and accurate. And something just happened here. Oh, okay. Because now I'm calling the time delta. So we need to do something like this probably. There we go. So what is Python doing here? It's doing first this subtraction, storing that in a temporary workspace as that time delta object that I showed you earlier. And then, so we wrap this into parentheses just to make that computation first. And then we call the days of that computation. And then when we get the 230, and after that, then Python adds the 1, okay? So there are like nested computations here. And sometimes you can split this into 2 steps. For instance, you could do something like this. You can do this like that. And then you can do, okay? So that will be another option. Okay, let's move on. So how do we find, now that we have the starting and ending, how do we select the rows that have the temperature and the, that we need? So for instance, these rows here, we don't need them. We also don't need them, these ones here, because they are after the harvesting time. So we need to only select the rows for the growing season. So how do we do that? Let's just select rows for growing season. So we need to find, again, using that Boolean, that true or false, we are going to select the rows that actually are within this period and the rows are outside of the period. So we are going to use a Boolean for that. And we are going to do index season. You can call it Boolean season, logical season, index season, anything you want. It's very common to, because we are indexing, we are sort of telling which ones, which rows meet or are in that period or not. And so this is actually fairly straightforward. So we are going to use df timestamp because Python now has everything in time, in date time format. So it will understand the dates in both the data frame and the start and end dates for the planting date. So we can actually do the operations straightforward. So we're going to use date timestamp that are higher or equal than our planting date. Know that I'm wrapping this in parentheses. And we are going to, again, wrap this in parentheses, the timestamp that are lower or equal than the harvest date. Know that you had to pass the timestamp twice because this is one statement and this is another statement. And it's only going to retrieve the rows for which these 2 statements are true. If one is true but not the other, then it will be false. Okay, both of them had to be true. So let's actually print this. And we see all these false, but we can actually try to look into more details. And let's see, I think it's 280 to 295. So we can actually slice this and access, let's say, rows 280 to 295. And here you can see that is the beginning, right? That's the beginning where we start. So right here is when we planted. And then there will be another 231 of this, and then it will come back to false. Okay, so this has the same size as our data frame. So now we can use this Boolean to retrieve the rows that we need. Okay, let's do that. So we're going to create another data frame. We're going to call it df season. You can trim the other one if you want, but I'm going to just leave it there because it's not hurting, and we don't have way too many things yet. But if you can also keep working with a single data frame and trim or drop the rows that we don't need. I'm just going to create a different one. So here we're going to use df, and now we need to access rows and columns. So I'm going to use the location way of indexing. So that's location, open square brackets, pass the index season, and then I'm going to tell all the columns. Here we can actually choose to only, since we are not going to use the rest, we can actually choose to only get the temperature. So you can do something like this. Let me just copy the name of the. So we can do something like this, like that, and like that. Okay, so in that case, we're going to get only these rows and only these columns. The other option is that we get only these rows, the ones that are true, the 231, and then all the columns. That's another option. So I'm going to do this one, and then we're going to use df season head and that. Okay. So now we got the data frame for the growing season, and you can see that starts from 287. This is fine when we are in the data frame with everything, but now let's restart this one so that we can, start from 0, because this is a new data frame. It depends on, if you want to keep track of what was the original row in the original data frame, you can just leave it alone. So this is create a new data frame for the growing season. Okay. And so now what we are going to do is replace or reset the index. So we are going to use df season. We are going to do reset index, and then in place true. Again, one more time, so that we don't have to redefine it. That means that it's telling, forcing Python to replace it in place. We're going to do that, and we can actually do it again. df season, always check your work. And now we have certainty that that we have it here, and we are also keeping track. We can also drop the other one. We can actually come here and do reset index, and then you can say, see if it says drop false by default, that means that it's going to keep the other index. But if we come here and we say drop true, oh, that did not work. Let's see if I can put it again. There you go. If we add drop true, then it will remove the previous index. Again, it's just a preference. I think it's not a bad idea to actually conserve the original index in case you need it in the future. But this is the beauty of the notebooks. You can reset your entire kernel right now, shut it down just by going here and remove all the outputs, and then redo everything again, and you're gonna get back here. So not a problem. Okay, let's keep moving. Reset index. So now we have that. We can actually, again, plot the data for the growing season and see if we got it right. So I'm gonna go up, and I'm gonna just copy this. And this is a little dangerous, but since we are a little running short in time, when I copy that, and before we run anything, I don't want, I'm gonna write this as figure 2. And we're gonna keep everything the same. Maybe we can say whether growing season, which is growing season here. And now instead of df, we need to call df season, right? Because that's our new data frame for the growing season. Otherwise, we're gonna replicate the same. So we need to change the x, and we need to change the y here. And I think, and then we need to display here figure 2. Okay, so now we have the growing season, and that looks about right. That is October, and that goes to the end of May and June. Okay, perfect. So before I go too far, I'm going to show you, for those programming in R, there is an alternative notation here, and I'm going to write it below here so that we can create. So instead of writing the XY kind of notation, you can write the source, which is df season, comma, and then you specify the X, and the X needs to be the name of the column that you want from that source, and then the Y, like that, which is going to be the temperature. So that's, and then the same for the other. Well, let's just leave them mixed like this. That's going to be okay. But see, you can actually use this notation. Specify the source, then do the X and then the Y. This is a different sort of a semantic or a different, philosophy on how we, create plots. So anyway, Bokeh accepts both of them. So sometimes this one is handy, and sometimes this one is easy. But that's your choice. Okay. So I believe this is more like a ggplot kind of way of plotting. So I'm going to delete this, but I wanted to show you that, you know what, maybe we can do this. We can do that. We can delete it. But now I'm going to add it as a comment here. I'm going to do a comment, and I'm going to place it there. Okay. So sometimes instead of deleting, you can actually comment out your code. And if you need it again, you can just remove this line, and then your code is fully functional again. Yeah, so try to use comments to your advantage. Now, don't do a lot of this, right? Because it's going to clutter your code, but it might be good sometimes. Or another option that you have is just put it below. Remember that Python will ignore any line that is, appears as a comment. Okay, so now we can do a few things. We have about 30 minutes, so we're going to do at least, find the max and minimum temperatures of the growing season, and then we are going to compute the thermal units. So find T max and T mean for the growing season. Hopefully you see that, this is fairly basic, but I want to, again, if you want to get started with Python, I think some of these basic computations are often pretty handy, and then you can go into something more advanced. In fact, tomorrow I'm going to show you a few other things. So Tmax and Tmin. Let's do this. So what are we going to do here? How do we going to use this? We need to use some of the pandas methods. So we can, for instance, let's do Tmax. And now we're going to use df season, right? So we just call that. And now we pass the variable that we want. Let's say that will be the temperature max. And now remember that in one we did sum. In this one, we can actually do max. And we can do that. And it ran, but it didn't show anything. So we can actually print this and see that it was 30.2 Celsius. So, and it's about right. It's this point right here. Okay, perfect. And now we can also do the same with minimum temperature, but what if we want to know what day this happened, right? What if we want to know which day this happened? So we can do again another Boolean index Tmax, and here we can do the same thing as before. So df season, and for temperature max, but instead of calling the max function as I did, we call the index max. And now you see what I call my variables index, because usually this is also part of the jargon in the library, index max. So this one will give us, well, let's just see what index Tmax, right? It's giving us 176, which basically means is a 176 row into the is a 177th row, is a 176 index in the data frame. So we can actually use this value to retrieve the timestamp. So we can actually do this day Tmax, and now we can do df season, and we can use again the same thing, that location. It's like we are going to access the location, the specific location in the data frame, and now we do the index Tmax, that's the row, okay? First rows and then columns. So let me just do that again. That's rows and columns. That's what we need to specify. Use index Tmax, and now we are going to do timestamp. That's what we want. See, it's not doing the auto-completion here, so I need to type it. And now we can print the maximum temperature was, and then we can put a space and pass here T max, and that's going to print Celsius. Let's forget the unit, and or to be or and now here we pass day. Next. Okay, so we have that. That should work. There you go. Okay, and it's April 8th. Is that about right? Yep. Okay, so we can do the same with minimum temperature. I will leave that for you to do as a homework. So let's do here homework. Maybe you were not expecting homework, but it's fairly easy. So find t-mean. So homework will be find t-mean and day of t-mean. Okay, so basically the same thing as this. So now we are ready to, that we computed some basic statistics. We are ready to compute the thermal time. And the goal here was to show you some of these methods that are available in the pandas data frame and how handy they are to access basic computations, particularly when used for the entire column. Okay, compute thermal time. And now for that, as you all know, we need to define at least a base temperature. And for wheat, I believe is 0. And we need to define an upper temperature. Sometimes it's not necessary. And I think for wheat, it's not going to have any effect. But let's just do it. Let's just say that is 35, 32 Celsius or something like that. We can actually add here a comment Celsius in the same here so that we know Celsius. Okay. And now we need to define what we are going to, how we are going to do the computation. So one way to do this is just looking at a paper, and you have the references that I used for this workshop in the other notebook. But one way of doing it is actually documenting what we are going to do. So for instance, what we can do here is add some equations. So we are going to do a Markdown, and I'm going to do only one or two. You can again go to the other notebook and see all the details. But I'm going to transform this into Markdown. And now I'm going to show you how to actually write an equation in the Python notebook. So we can do, let's just do one simple. So that will be double dollar like that. And we can do, say, x or y equals x squared. Okay. And if we do Control Enter, then we have an equation all of a sudden right here. Okay. So pretty handy. So we can double click there, and now we can actually write an equation that we are going to do. So we are going to say if the the average temperature. So I need to do the the subscript. So subscript will be underscore, and then everything that we want under subscript will be a curly brace average, and then we close. If you don't use the curly braces, it will only do subscript of A, and the V and the G will look larger. See that? So if you want to make sure that everything is, then you just use curly braces. There we go. So if the average is lower than T base, then what are we going to do here? Then we are going to assume that the thermal unit equals to T base. Okay, so we're going to do that. You see that everything appears a little too cluttered. We can actually add some forward slashes, and we can add a little. Oh, that didn't work. Maybe the comma was not a good idea. Okay, I'm in a Windows machine. Let's see that. That seemed to add a little more space. Okay. Then, okay, you can find a way to make it a little prettier. LaTeX has a ton of specifications on how to do this. So I just want to give you some rough idea on how to implement an equation. And then, so in this case, basically what we're going to do is if the average temperature is lower than T base, we are going to assume 0 as our thermal units. And if the daily temperature or daily average temperature exceeds 35 Celsius, then we are going to assume that that day we gain only 35 thermal units. We are going to ignore the excess of that. Okay, so let's just write that one for here. So if T average is higher than the T upper, then TU equals T upper. Okay, and the last one will be basically is TU else is TU equals T average minus T base. That's basically what we're going to do. Okay. I'm not sure if I made a mistake, but I think you get the point. And just want to get to the solution so that we can plot it and we can finish with the exercise. But everything goes together. So figures, equations, that's what is really neat. So now we need to do, we need to compute average temperature. So compute average temperature. So we are going to, you can just compute it like this and have it as a variable, but you can also compute it and add it to the growing season. So we can actually add it to this one so that everything stays together. So I think that will be probably the best way to go here. So first we are going to do the temperature average, the average temperature, sorry. So we're going to use df, and then it's going to be temp min plus df temp max, all of this divided by 2. And now this seems very straightforward, but I really want you to understand what's happening. Is grabbing this entire column plus each element of this other column. So for each is adding the matching rows, and then the result of all of that, of that sum, that will have 231 rows. Each element is divided by 2 to compute the average. So this is called an element-wise computation. Okay. So it allows us to do all the columns. So if you have 1 million rows, it will do the average temperature for 1 million rows in one line of code. Okay, so we have that, and now we need to add it. So we're going to use df season insert, and here we need to define where do we want to insert the column. So let's see, maybe it's natural to put it right here at the end, or maybe somewhere closer to the temperature. So that will be 0 will be right here before the timestamp. 1, 2, 3, and 4. Okay, so this to 4. Insert position number 4, and then the variable that the name that we want is going to be, let's use the same temp 2 meters average. So I'm going to use the same notation, and then the variable that I want to pass is the one that we just computed. Okay, we're going to do that. And then we're going to use df season all in one goes to check our work. And indeed, right here. Something didn't go right. So that's not the average temperature. What did I do wrong? Okay, I'm not sure what I did wrong. Okay. Somewhere we messed up, or I messed up.
You use df instead of df season on T average.
Oh, there you go. Who was that? Leonardo? Awesome.
It's Leo. Yeah.
Yeah, Leo, perfect. Yeah, so that is one of the, very good. That is one of the risks of, well, 2 things. The risk of having too many variables that you may, after coding for 2 hours nonstop, you may not see exactly the problem. And this is what happens all the time. So maybe I think it's worth stopping. The errors that you cannot see are the worst, because it seems that everything was fine. And, we are blind to many of these things. And so, but the other thing is that I would have never found this if I was not checking my work here, right? So always check your steps and then make sure that before moving into the next step that you know that exactly the computer is doing. This is a classical example where the computer did something valid, but it was not what we meant it to be, right? So, and this is one of the reasons I really like the live coding sessions, because you don't get to see these things in YouTube videos, or you don't get to see these, in the tutorials. Everything is already polished. So let's move on now. Hopefully that will fix it. So df season plus df season, and I don't know what I did. Now let's see what is the error. Cannot insert temperature. Oh, okay. So it already exists. So we might need to redefine it somewhere here. So I'm gonna do that. Let's see, what is the first one? That I'm gonna rerun the code here so that we get a fresh. There we go. And now it looks decent. Okay. So yeah, the error message also, don't freak out. That's going to happen all the time. So make sure you read the error message, try to interpret it. And it was not obvious that there was already a column, and pandas, it was preventing us from adding another column with the same name. Maybe a feature could be that it should override it. But it was sort of giving us that nice message, or that nice error message, that not allowing us to do it. And it's just preventing to create a mess in the data. Okay. And again, if I rerun it, you will run into the same problem. So in that case, it was probably better to use the plus sign right there. One more time, one of the reasons I love the notebooks. Everything is very, very handy and reproducible. So we are almost close to the end. So I think we're going to finish right on time. So we need to do now the computation of the thermal units. And in many cases, you will write something called a for loop for this. So you iterate over each row, but we're going to do everything in a single line of code. So we're going to use thermal units daily. This will be the thermal units we accumulate per day. So we're going to define it like that. And then we are going to use, so now to do this, we need to use another library called Numpy. And here is when I'm going to go up, and I am going to, where's the modules here? I'm going to come here, and I'm going to say import Numpy as NP. Don't forget to rerun this. It's not going to change your code or anything, but it's going to import all the modules, including Numpy. And maybe here there is a specific mention. So Numpy is a numerical Python. Was inspired in MATLAB, and it basically, I think 75% of the data science modules in Python use or are based on Numpy. In fact, Pandas is built heavily on Numpy. It's very fast. It's not coded in Python. It's coded in a hybrid language called Cython, which is really fast. And that is why it can make many, many operations per second. So that's why Pandas is actually really fast. So if you want to read, let's say, a file that is 100 megabytes, like a genes database or something like that with Pandas, it will take a fraction of a second. It's just really fast. So now we need to do, Numpy, and we are going to basically use this logic that we have here. So if the thermal unit is higher than the T-base, then we are going to keep the average temperature. So we are going to keep the maximum of df season. There you go. Average temperature. And then we wanted that one on T-base. So T-base was 0. And this is why you want to allocate things in variables. You don't want to do this. This is called hard coding. And when you hard code something and you have many of these lines, and then you need to change it, then you need to replace this number multiple times. And it's kind of hard sometimes to find all the instances where you wrote this 0 or any variable in your code. So that's why it's better to allocate the variables in one place and then make use of them. So T-base. Okay, so it's the maximum. So if this one is, to say, negative, then it's going to keep the T-base, which is 0. And on top of that, we are going to the same way. If it exceeds the upper temperature, we are going to use the upper threshold. So we're going to do MP minimum. We're going to use the minimum of all of this or T upper. Okay. And then we are going to print this to see what's. There you go. So that's the daily thermal units in a single step for all the growing season. I mean, that's quite impressive. But now we don't care about the daily. We care maybe about the cumulative, right? So how the growing season is accumulating the thermal units. So we can actually create another variable called TU cumulative. And now we can do TU daily, and we can actually use the cumulative sum. And that should, let me just print it here, TU cumulative. And there you go. Now you have the cumulative growing degrees for the entire growing season. You can even simplify this further. Look, you can actually wrap all of this. I think it will work. Let's just give it a try. You can wrap all of this, and then you can do the cumulative sum right here. And let me see if that works. Let me just copy this and I don't want to screw anything up. It's just back here. Okay, it does work. So you can actually have everything in one single line of code. You compute both the daily and the, well, you don't get the daily, right? The daily is here, but it's stored in the workspace that we don't get to see because it's generated on the fly. And then, Python at the end of that will compute the cumulative sum, okay? So, but that will be if we are not interested in the daily thermal units, which actually we are not. We can do everything in a single statement. Yeah, I'm gonna delete this. This is okay if you are, becoming more confident, but see how many things are happening. Python is first doing this part. Then the result of that is, is the input for the minimum, which is doing this part. And after that, the result of that is doing the cumulative sum. So there are three nested operations from inwards and outwards. Yeah? So this is fairly complex. I think many people will call this Pythonic, but if you're a beginner, you might call this, a mess. So I would probably not encourage you to do these kind of statements at this point. I will just delete that. Just want to show you what's possible. Okay, we have that, and now let's actually add the cumulative thermal time to the pandas data frame. So we are going to come back here, and we are going to grab the same thing that we did, and we're gonna do DSC. So we are gonna insert it. We are gonna insert it at the end. So we are going to call the length of the data frame season columns. Right, so that will give us the last place, and then we are going to give it TU cumulative, and now here we want to pass this one, which is computed, so TU cumulative, and then we are going to again df season head just to make sure that we insert the things, and there you go, it's at the end, and it's looking right. But it's looking right, but we don't have a specific check. So let's actually go and compute, let's plot the one more time the same mistake. Let me just do this again. There we go. Probably need to do a few more. So okay, so now let's do a plot of the thermal units. So plot thermal units, and let's do figure 3 is going to be equals to figure, and then we are going to, we can use the same thing. We can, since we are short of time, we can actually copy this part here. Let's copy the first part. So it's going to be a date time. It's going to be the same dimensions. We can just place maybe growing degree days or thermal units. Thermal units. Okay, we have our figure object, and now we need to add a line, so a 3 line, and now we need to pass the. Let's just use the R notation. So source, and we're going to use df season. Then we're going to pass X our timestamp. The only thing I don't like about this one is that it doesn't have the auto completion. So timestamp, we have to type everything. And Y will be the TU cumulative. Okay, and then we do show F3. I think that should do it. I don't know. Did that work? That doesn't look right. And what did we do? DF season. Okay, might be right or not. I'm not sure. It doesn't look right because during the winter it should have less. When there is another mistake that we did somewhere else here. Let's see if you can find it. Okay, so now we need to start doing some checks or something just to figure out what's going on. So anyway, this will be the end. The line should look a little slightly different, but it's not not much different from this. It should be a little more a little noisier. Someone has a comment there. Let's see. Okay. So anyway, I'm gonna try to troubleshoot this quickly so you see how maybe someone can actually inspect this, but this will be the end. But let's do a few tests here. So we have TU cumulative, and then we can start printing this and see that something happened, that we have values that are excessively large here. So we have 14,000, which is not real. Okay, so something happened when we did this sum. I wonder what I did here wrong. Season mean plus, okay, that seems to be right. Maximum, the minimum, T upper. Oh, okay. What happened is that I show you how to do this quickly in one statement, but I left the cumulative sum here, and I also have it here. See? So it's like we computed the T daily, and we already computed the cumulative here, and then I call that and I sum it again. Okay. That is what we need to do. We need to remove that, but now when we add it here, it's gonna complain. So let's just add it. Let's run it again from here. And I think now it should work. There you go. Okay. And then we can add maybe just the axis label, and we will be done. Y-axis, the axis label. You can use the autocomplete. Sometimes, so if you're using a Mac, it will be a little faster. For some reason in the Windows, sometimes it has a little lag. So axis label, and here we want to use thermal units, and this will be centigrade, centigrade day. I think that would be string not callable. Oh, because it should be equal, maybe. Yeah. Okay, so that's all. I'm not sure if there is, oh, maybe there is one more step. Let's see, how do we find the total? Because, we see that here we have roughly 1,600 days, but how do we access the total? So let's access that. So find the total thermal units for the season. How do we find that? So we can. So in this case, we just need to access the last element of the cumulative. Okay, so that's basically what we need to do. So we are going to use TU total, and then we are going to do df season, and then we need to use TU cumulative, and then we need to access the last one, which is we're going to use the integer. There are two ways of accessing this. This is one, the integer location, because we are interested in the last one, and then that should print it TU total. And what did I do wrong now? In columns, oh, of course, you need to have this as a string here. There we go. So just to finish it up, print the total number of thermal units in the growing season was. And there you have, and because maybe our method is not that accurate, maybe we can just use the round function one more time and round it to, to the nearest integer. So that way, and then there you go. Okay, so that was 2 hours nonstop. So if you were able to cope with this, you did really good. I'm tired, and you can see that I've been doing quite a bit of mistakes at the end, but hopefully this will get you started. There is something else that we can cover tomorrow about how to use these, these thermal units to run a simple model. But I also want to show you maybe a few other plotting libraries and maybe how to do, a few other common tasks in agronomy. But the ecosystem of Python is very, very large. And really trying to condense everything in a single day or even 2 days or even in a semester sometimes is really hard. So hopefully with this you will have some a way to get started. You will know how to at least access some of the documentations online. And if you have any questions, feel free to place them in the chat now. It will take a few minutes to read them all, and then I will try to follow up or even add some of your concerns or questions in the notebook. So I will be uploading this one to the Github repository again, because it's not exactly the same as the other one, and I really want to conserve many of the things that we did today.
Okay. If you're okay, Dr. Patrignani, to stay a couple of minutes to answer any specific questions that attendees may have, just, 3 to 4 minutes. And then we may wrap up the session. So I don't know if anybody has a question. Okay, it seems that we don't have any question. So with this, Dr. Patrignani, we appreciate very much your support to this first introductory coding session. We know that it's very hard. So we hope that attendees were able to follow along. And thank you very much for joining us today. And we hope to see you tomorrow at 4 p.m.
Okay. Yeah, it will be nice if someone found this either too fast or too slow or something that that they send you some comments or some feedback so that we can adjust it. So anyway, I think it will be nice to receive something if we need to change. But other than that, I will use it more or less a similar format. And again, you can always go back to the notebook that is in GitHub just to run it on your own. Thanks, everyone.
Hey, Andres. So I just have a quick question.
Yes.
This is Leo again. So, I mostly use R in RStudio, and one of the things that I was looking for and kind of missing from the RStudio IDE is to have a table of contents somewhere, just to kind of, especially with the Markdown, as you have those different heading types and levels. Like if I just wanted to ask you, like, if there is a way to make that table of contents pop up somewhere so we can browse your code more easily?
You can add a table of contents in Markdown, and I believe there are some tutorials that I have in a website I will be sharing tomorrow that has that. And I believe there is a way to add the table of contents right here at the beginning, but you need to then follow. I think it's gonna maybe follow the titles maybe first or second order. So I will try to. I've done it in the past, but I don't remember if I did it in the notebook or in in the exported version already in Markdown. So I will try to add that into the into this version or even the other one in GitHub after we finish. But I think that's a really good question, and that helps a lot. If we're doing a tutorial or something, so that people can go to specific points. So yeah.
Awesome. Sounds great. Thank you so much. It was very helpful.
Yeah. Thank you, Larry.
Sorry. I have a question as well.
Okay.
Very nice workshop first. And then my question is, so you use the dot sometimes. I don't know if you're familiar with the pipe function in R. It basically takes the object you have at your left and puts it in a function as a first argument, which is at the right.
Okay.
And I saw you used it sometimes kind of similar to the pipe, like you take the thing you have at your left, and that would be the first argument in that function. But then you showed like a nested kind of like
Can you point exactly where in the code so we can look it up?
It was below. I don't know if you kept that part of code. Yeah, that where it says TU daily.
Okay, here.
Which you have like nested functions, I guess.
Yes.
Could you do that with a dot as well?
You can place a dot at the end, as I said, and do the cumulative sum, meaning that you grab all of these, and then that will be the input for the cumulative sum, right?
Yes.
So that's more or less what I think you're mentioning. But with the dot notation, we are accessing either properties or methods of the object. So this is an object. The result of this will be a Numpy object. And that Numpy object has a method called cumulative sum that we can apply. But we can only apply methods that are in the object. So we cannot apply, if we wanted to apply something else, then we will need to use a traditional function like something like this, I don't know, like standard deviation. So you will need to wrap everything here and then close it at the end. That will be for a function that is not in the object. So it all depends whether that method or function is available or not.
Great. Thanks.
Okay, great question.
Okay, it seems that were all the questions we had. So again, Dr. Pratignani, we appreciate your time. It was a really nice session. And thank you all guys for joining us today. And we hope to see you tomorrow again at 4 p.m. with the same Zoom link.
Yeah, thanks everyone. Adrian, is there any way to save the chat? I don't know if there is much, but just in case we.
Yeah.
You can copy. Yeah. There you go.
Were you able to save the chat? I save it.
Okay, you say I copy pasted in the notebook, so I may actually even keep some of the comments in the.
Okay, I